Welcome to the Level 1 Utah lecture on mineral formation. There are three ways that minerals can form. The first way is through magma cooling down. Atoms inside magma can move around freely. As they move around and find each other, they will bond and form a crystal. Minerals will bond at different temperatures. So here at 1200 degrees Celsius, this green mineral will start to bond and form crystals. As the magma starts to cool, we then get these darker green ones bonding and forming crystals. Here at 600 degrees Celsius, the white crystals will now find each other and bond and cool. The rock granite is a good example of minerals forming as magma cools. In this example, we have this pink mineral here, which is plagioclase feldspar. The whitish minerals here is quartz. The black mineral here is usually amphibole or plagioclase feldspar. So as the magma cools, these different atoms find each other and bond and grow crystals. The second way to form minerals is through evaporation. If there is water with minerals mixed into it, the water will evaporate, leaving behind just the minerals. If the water continues to evaporate, we're just going to have the minerals left behind. And that would form what is called an evaporite. One example of this is halite. This is Great Salt Lake in Arizona. This is right outside Salt Lake City, Utah. Every time it rains, the rain will run across the land, dissolving any salt that might be in the rocks or soil. The salt is then deposited here in the lake. However, there's a high rate of evaporation, so the water here evaporates pretty quickly and leaves behind the salt. Here is a picture of my brother. He is not treading water or anything. He is just sitting there. Because the lake is so salty, it actually lowered the density of the salt, which will allow people to float very easily. Here's another picture of my brother laying there in the water with his legs crossed and arms crossed, just floating. Here's a picture of my dad floating in the water, hands and feet both out of the water. Notice how high he's even sitting in the water. Again, this has to do with the density. The density of the water is so great compared to our bodies that we will float higher in the water. As the water evaporates, it leaves behind the salt. So what you're looking at is a huge flat field of salt. Another term for salt is halite. Here's another picture of the Great Salt Flats. You can see the white as far as you can see. This is all salt. This is my brother and I standing on the Great Salt Flats. We were rocking the fanny packs. The third and final way to form a mineral is through precipitation. Precipitation occurs when a solution cools down and it can no longer hold the atoms dissolved into it, so they precipitate out and form a mineral. Hot solutions can hold more atoms. An example would be rock candy. If you boil water, it'll dissolve more sugar. As that water cools down, the sugar can no longer be held in the water, so it precipitates out, forming a piece of rock candy. Another example are the chimneys found on the sea floor. As hot water rises through the oceanic crust and it hits the cold ocean water, it will precipitate, and these form chimneys on the bottom of the ocean floor. Another example are springs. Springs will often dissolve minerals as it travels to the crust. When it reaches the surface, the minerals will precipitate out. So this spring used to be in the water, and it formed this big bed of precipitate. Here's another example of a spring in Saratoga Springs. The spring is up here, and the water flows down, and as it flows down, it will precipitate the minerals it's carrying. This spring has a high rate of precipitation. When leaves fall on it, it'll precipitate and get stuck in the spring. This spring precipitates so quickly that if any insects land on the wall, it'll actually get stuck on the wall and stay there forever. Another example of minerals precipitating is Mammoth Hot Spring. This created a huge wall. To give you scale, this is my brother standing right there. One last example is in Yellowstone National Park in Wyoming. Here the hot springs dissolve a lot of minerals in it, but near the edges, as it starts to cool down, they will precipitate out, forming minerals. The color, however, has to do with bacteria. The bacteria eat the minerals dissolved in the water. So this bacteria tends to be brown, and it likes the cooler temperatures. As you move closer to the center, the color changes because the different types of bacteria change. The deep blue color has nothing to do with bacteria or precipitation. It is simply completely sterile because it is so hot.